Good morning, Malaysia! How's it going, everybody? How's it going, Year 10s? Thanks for coming along. Right, so today's lesson, iGCSE Acid-Base Theory, Lesson 4. It's actually on titrations, but what's stoich? Stoichiometry is the study of balancing equations. Why do you ask that? Where do you come across stoich? Stoichiometry. Stoichy. So I'll share my screen. I'm going to crack straight on with today's lesson. It's going to be quite short. I am very aware that I'm just going to be going through the initial stage of this lesson is going through the previous homework. For those YouTube, hey Winkit, good to see you. Good luck, Winkit, today with Unit 4. You're going to do great. So I'm going to go through the homework first of all, guys. That is a priority for me. It's very, very important. This activity that I've set you from Edit 4 Edexcel is so crucial. It comes up a lot at GCSE, and so I want to spend the time and go through these. So we may not get on to my lesson on titrations today, depending on how many questions I've got. Stoicism. In the sense of stoicism. Yeah, stoicism is just balancing equations. Right, let's share my screen. Let's crack on. Sorry, I need to get going on this. So let's share my screen. I'll also check that everything is working. Yeah, that's all good. So I'll close that now. I've got my chat popped up. There's my screen. I'm going to switch over to my clip cam so you guys can see me. Way! So we can do any dancing that I need to do. Right. Okay, guys. So I'll minimize that now and switch my tablet into tablet mode. Okay, so the homework now, what I'm going to do is for those YouTubers, my subscribers, what I'm going to do is I'm just going to quickly leave the page up there of the homework, which is here. There's the homework in its entirety. And if you want to know at this point, if you're one of my YouTube subscribers, then you won't have had access to this sheet as the homework. So I post it on the Google Classroom. So what you can do is if you just screenshot that now, you can then have a go at this exercise before I go through it. So please feel free. So first one, yeah. So what I'm going to do is at that point, screenshot me, and then you can then start going through it and then unpause the video when you're ready. So the first thing that the exercise does is, and this is very much from Key Stage 3, this is the first time you really come across this is in Key Stage 3, but it is also heavy Key Stage 4. So these are the general rules. And please note this one here. The last one is super important because it comes in Key Stage 3 as part of diffusion, and I'll make a reference to that in the video. So let's go through them. So question number 1, I'll do these in red, why not? So, and you guys can tick this off when you've done it just to see if you get it right. So metal plus acid creates salt and hydrogen. And you've got to do this in words. These are the generic equations. The next one, metal oxide plus acid gives salt and water. Next, metal hydroxide also gives salt and water. These two you link together. Yeah, because they're the same outcome. Same products. Yeah, the balancing is different, but the products are the same. Metal carbonate is salt plus water plus carbon dioxide. Very common still at GCSE for these general equations to be used. Still very common. The next one is very strange. Ammonia plus acid simply goes to salt. Let me show you why. So just to show you why this is, ammonia is the base. So ammonia is NH3 and it's a base, and we can put underneath that proton acceptor. Yeah, that's the definition by Bronsted-Lowry of a base. It is a proton acceptor. It can accept H+. Now we're going to add an acid to it, like hydrochloric acid. Let's add HCl, and this is going to be our acid, and this is a proton donor. Proton donor. There we go. And what's now going to happen is the H in this equation is going to get transferred over to the ammonia. Yeah, that's what's going to happen here. And what I form is ammonium chloride. So I just simply get the salt. Yet there's no water because there's no oxygen there, and there's no hydrogen because the hydrogen is actually joining to the ammonia in the process. This is ammonium chloride. Ammonium, please notice the yeah, ammonium chloride, and the difference between that and ammonia. Yeah, that's so important. I cannot stress that's one of the things that you learn, which is so important at GCSE, because it carries all the way through your chemistry careers. That does. Ammonia is NH3 and ammonium is NH4+. Now, just to also tell you, it's nice for us to do a little bit of question and answering here, which is both of these two. I'm going to ask Jack. Jack, what type of bonding is in both ammonia and hydrochloric acid and hydrogen? In fact, in this case, hydrogen chloride. What type of bonding is this, please? Bonding type. Bonding? Question mark. The next thing is I'm then going to ask Owen, who's going to really impress me. Owen, what type of bonding is in ammonium chloride? Bonding? So I've got Jack answering the first two and then Owen answering the second one. The second one is much more challenging because it breaks a chemistry rule. We can also have a look at another equation while you guys are doing that. Another example of this is if I do ammonia, which is the base, and I'm going to react it with nitric acid, HNO3, and this is my acid. And in this case, the proton gets transferred over to the ammonium from the NH3. Jack, well done. These two are both covalent. Well done. And that's because they're all non-metals. Great job. Jack, now you can impress me further. What does that tell us about their boiling points, please? Will they be high or low? Still waiting on Owen on the next one. So we can complete this. Guys, can you now have a go at completing the product of this one, please? Yeah, pause the video and have a go. Yeah, this is going to form, once you've had a go at it, you can unpause it. This is going to form ammonium nitrate. Yeah, this is ammonium. Notice the reappearing. Ammonium nitrate. The NO3 becomes the nitrate group. This is where I can color code things. The nitrate is NO3 1-. Yeah, there's the nitrate. Darn it, I keep missing the N. There we go. Ammonia, and the ammonium, of course, is the NH4. It's nice to color code those things. Low boiling point. It's covalent, not sure. Yeah, right. So Owen, this is why it breaks a rule, because it turns out, well done, Jack. Covalents all have low boiling points. The giants have very high boiling points, but the simple covalents are going to be low. Well done. Low boiling points because of WIMPs. I'm going to ask Lauren. Lauren, can you do me a favor? Can you translate on the chat, please, to my YouTube subscribers what WIMPs mean, please? What does the word WIMP mean? So ammonium chloride, Owen, is ionic. It's ionic. And it's a very odd one. It breaks a rule. It's all non-metals, but actually it's a rarity. It's ionic because I actually have NH4+, and Cl-. That's what I actually have. It actually turns weak intermolecular forces. Well done, Lauren. Good job. So it's an oddity of the world, and it's something I need you guys to learn. All ammonium salts are in fact ionic. This is a nota bene. Nota bene. Yeah, important notice in Latin. Yeah, all ammonium salts, all ammonium compounds are ionic with high melting points. Yeah, with high MPTs, high melting points. Yeah, because the electrostatic attraction is incredibly strong. Cool. So it's nice to do that. Well done, by the way, for Callista for getting ammonium nitrate. Well done. Now I'm really gonna push you guys a bit further now. And you guys are gonna really impress me. Ammonia plus sulfuric acid. Now you can really impress me. What am I gonna make here? Wow. Oh, it's because the NH4 is a cation. Yes, Owen, absolutely right. This is the cation. Yes, well done. And this is the anion, the onion. Do you know what? I love a good bit of onion on my hot dogs. see what I've done there? Onion's a bit like onion. Onion. I'm gonna stop. So guys, you can really impress me now. Now I want Callista. You're gonna blow my YouTube subscribers' minds right now when you get this right. What am I going to get if I do ammonia? Oh, good, Lauren! Yes, Lauren, I am so impressed. Well done. We're gonna form ammonium sulfate in a bracket. Well done. And then you've got a balance. Ah, you see, Callista, that's not quite right. The nitrogen can only pick up one anion. I'm glad you appreciate that, Jack. Yeah, each ammonia actually only picks up one H. Remember, you've got to learn your ions, Callista. Yeah, you've got to learn that NH4 plus is the ammonium ion. So let's do the little cross and down trick. Ammonium ion and the sulfate ion. So we've got, if we have an ammonium ion, which is NH4 plus, and we have a sulfate ion with an F, not a pH. pH is an ancient English misspelling. SO4 2 minus. We've got to do the stupid cross and down trick. I'm going to need 2 pluses to cancel out the 2 minus. So I'm going to have to bring that 2 down, put it in a bracket so it doesn't look like 42, and I get SO4 1. I hope that makes sense, Callista. Yeah, give me a thumbs up on the chat if that makes sense. And then you've got to balance it. Well done, Lauren. Super impressed. Good job, young lady. That is superb chemistry. It's great progress. Well done. Thank you. So, and again, this is acting as the base, and this is acting as the acid, and it's transferring one hydrogen ion to each sulfate. If you want, to each ammonia. If you want to actually see what's happening from a molecular perspective, here's what's happening. This is sulfuric acid. Here's what's happening. Yeah, so this is sulfuric acid. And what happens is the ammonia comes along with its 3 bonds. Ammonia comes along and it steals the hydrogen, and that then rolls back. Yeah, and then another ammonia comes along and steals the other one. This is what's happening on a molecular level. Yeah, that takes that and that rolls back. I'm showing you what's happening in terms of electrons here, guys. But what's happening is this is stealing, yeah, stealing the H plus, yeah? And this is doing the same thing. Whoops, stealing H plus, stealing H plus. So what then happens is you then end up with this picture at the end of NH4 plus because it's gained a H plus on it, yeah? The ammonium ion there, and this is the hydrogen it stole. Yeah, we then have the SO4 2 minus ion, which looks a bit like this. Looks a bit like this. Yeah, 2 minus. Yeah, and then another ammonium on the other side. It's just nice to see it from a molecular perspective. Yeah, I always think there's lovely detail here, and this is the H it stole. Yeah, and it stole them. Technically, each of these oxygens down here are negative, and hence that gives the 2 minus charge. But it's really nice that. It's nice to look at things in terms of actual proton transfer. Yeah. So this is a neutralization. Yeah. Neutralization. Proton. I won't bother with that one. So, okay, let's continue with this now. So we don't get any water. It's kind of cool. This one now, oh my goodness, EdXL. Every GCSE, iGCSE, every paper. Yeah, they love this, guys. They love this. Making salts. So they just simply say, state the salt from the reaction. So we've got, complete the name of the salt formed when the acid reacts. So nitric acid plus sodium carbonate. And it says give the name, not the formula. I'll actually do both. So this is going to be sodium nitrate. And its formula would be NaNO3. I'm actually going to shrink my pen here, guys. Yeah, next one, hydrochloric acid and sodium carbonate is going to form, tick it, by the way, if you got it right, sodium chloride, formula NaCl. And the last one is sulfuric acid. That's going to form sodium sulfate. Oh, sodium sulfate, its formula would be Na2SO4. Yeah, tick them if you got them, guys. 3 marks. 1, 2, 3 if you got the names of each. Next, I'm now going to form magnesium nitrate. You realize they're just constantly stealing. The metal is transferred. Magnesium nitrate, which would be Mg brackets NO3 twice. And the hydrochloric acid would be magnesium chloride. Whoops. Magnesium chloride. And the formula of that is going to be MgCl2. And then magnesium sulfate. Magnesium sulfate. And that one's going to be MgSO4. And it stops. There's no 2 in that one because the Mg is a +2. Tick them if you got them, guys. 3 marks. 1, 2, 3. Next. Potassium oxide and nitric acid is going to form potassium nitrate. Metal swaps, takes the nitrate, which would be KNO3. Next, I'm going to form potassium chloride. Potassium chloride. And that's going to be KCl, 1 + 1 -. And then the next one's going to be potassium sulfate. Potassium sulfate. And that one's going to have a 2 in it. That's going to be K2SO4. If anybody... Oh, I did all the equations and balanced. Oh, no, I did all the equations and balanced them. Down here. Yeah, that's okay. That's part B. That's part B. Oh, Lauren, that's amazing. I love the fact that you've done all the equations for those. That must have taken you ages. Ages and ages and ages. Even with symbols, that's complicated. Because it's 3 per line. 3 times 5. So 15 equations. I can do them all for you, but it would take me a while. For part A. Wow, Lauren, I'm impressed. I could try and do them all. It's going to take me a while to do that. Like, I reckon it would take me about 5 minutes to do that. Let me finish this one first. Copper hydroxide plus nitric acid is going to form copper nitrate. By the way, it's actually going to form copper 2 nitrate, by the way. Just always remember to add the number 2 in for copper. And that's going to be Cu brackets NO3 close brackets twice. Then we're going to form copper 2 chloride. Copper 2 chloride. You have to include the Roman numeral because it's a transition metal. CuCl2. And then we're going to form copper 2 sulfate. Copper 2 sulfate with an F. And that one's just going to be CuSO4. That's blue, of course. Next, ammonia and nitric acid is going to form ammonium nitrate. Ammonium nitrate. A formula will be NH4NO3. Then ammonium chloride. Ammonium chloride. It's really tough getting in all the words to this, which will just be NH4Cl, and then the ammonium sulfate. Ammonium sulfate. So can I ask now, which it will be NH4 close brackets 2SO4. Can I just quiz? That's out of 15 marks, folks. Can I just have a quick show of numbers on the chat, please? How many out of 15 did everybody get? That would be great. I'd love to have a bit of feedback on that. Lauren, do you really want me to do all the equations for those? I can. It'll take me ages. Take me longer than that. Because I've got 3 for each line. I can. 15 out of 15. Well done, Jack. Gayatri, 12 out of 15 is really good. Well done. Tanisha, 15 out of 15. Well done. There, guys, I'm so impressed. Well done. Really pleased with that. Great job. It's my fault. Oh, no, Lauren. Can I just say, Lauren, it has such great value to do that. Such great value. Well done, everybody. Next, right, part B. Now complete the following word equations. Iron plus hydrochloric acid is going to form iron chloride. Oh, by the way, Roman numeral. Iron will probably form iron 3. It's more stable than iron 2. So let's go for iron 3 chloride. plus hydrogen gas, plus hydrogen. Right, let's convert that into a symbol equation. If you've done iron 2, would it count if you got the word correct but the symbols wrong? Gayatri, I love the fact that you've done the symbols as well, like I have. Just make sure that you've made the correction on how to make the symbol equation, because it's technically much more important that I get you to be able to do the symbols rather than the words, because it's much more challenging. If you need any help with doing those equations, those formulae, please let me know. Right, so let's now, underneath that, let's now convert it to a symbol. Fe plus HCl goes to iron 3 chloride, FeCl3 plus hydrogen gas, which is H2. Don't forget H2, yeah, and balance. One iron, one hydrogen, 2 hydrogens. That's not good. Let's balance it. Put a 2 here. 2 hydrogen, 2 chlorines, 3 chlorines. Oh, that doesn't work either. So we now need a common denominator, which will be 6. Yeah, so I'm going to put a 6 in front of this one. Yeah, to give the common denominator 2 and 3, and then put a 2 in front of that. Yeah, let's do that. There we go. Now I need to balance for the ions, and now I need to balance the hydrogens. 6 hydrogens. Right, take it if you got it, folks. 2 marks. 1 for that guy. And what I ought to do, actually, is actually do them next to it. So I'm going to move all of my ammonium diagrams, move all of these over. Yeah, let's move all of these over. There we go. A bit further. There we go. And then I can put the equation directly next door to the one I've done, which makes more sense because you can then see it. Oh. Directly next door, and then you can mark them independently. There we go. Get rid of that tick and put that 6 back. There we go. Guys, tick it if you've got it. 2 marks. Next, the symbol equations are much more important in reality. Let's go for the next one. Hydrochloric acid plus copper. They're not giving us any numbers anywhere. So that's going to be copper 2 again. So this is going to be hydrochloric. So I'm going to form copper 2 chloride. Copper 2 chloride. And now I've got a carbonate. So there's my salt. I now need water. Whoops. Now I need water and also carbon dioxide. Tick it if you've got it. Carbon dioxide. Let's now convert that into symbol. Hydrochloric acid and copper carbonate. So this is going to be hydrochloric acid, HCl plus CuCO3 goes to CuCl2 plus CO2 plus H2O and balance. I think you'll find it now balances. Tick it if you got it, folks. Tick it if you balance. Oh, sorry, it only says to do the equations for 2 and 9. Oh. 2 to 9. It's all right, just do them all. They're saying to not do the last one. I don't know why. It's weird. I'll just do them all, Jack. So iron 2 hydroxide will form iron 2 sulfate. Yeah, so this is going to form iron 2 sulfate. The 2 will always copy over depending on what they give you. So if they give you 2, it copies over. Hey, Harry, good to see you, dude. Just doing some equations, Harry. These are really good practice for you, actually. Iron 2 sulfate, and it's a hydroxide, so I'm just going to get salt and water, and it stops. No carbon dioxide. Right, balance the equation. Write the symbol equation. So iron 2 hydroxide, iron brackets OH2, plus, what acid was it? Sulfuric, plus H2SO4 goes to iron 2 sulfate. Yeah, iron 2 sulfate plus H2O. Balance the equation. And I'm going to need 2 waters, and I'm done. Tick. 2 marks. Tick and tick. Harry, I want to say good luck with today's paper. You're going to do great. I know you will. Next, nitric acid goes to word equation, calcium nitrate. And it's an oxide, so it's just salt and water. Calcium nitrate plus water. Now jump to my symbol equation, which is calcium, was it calcium oxide? CaO, this is tricky, this one. CaO plus, was it nitric acid? Yeah, plus nitric acid, HNO3, goes to calcium nitrate, which requires a bracket, really tough. This is all level 9 stuff. And this is an oxide, so I'm going to get H2O, balance the equation. Going to need 2 nitric acids. Tick it if you've got it. Next, I'm running out of space. Sulfuric acid ammonia forms ammonium sulfate and stops. Ammonium sulfate. Let's write the equation. So ammonia plus sulfuric acid, H2SO4, goes to ammonium sulfate, NH4, close brackets, 2 SO4. Done. Balance the equation, 2 ammonias. Next, oh, they've flipped it over. Zinc sulfate, carbon dioxide and water. Right, this is a carbonate. So this is zinc carbonate. Zinc carbonate. And I know it's a carbonate because of the carbon dioxide, Lauren. That's why it's a carbonate. It's how it tells me. It's a clever thing to do that. And then what acid did I add? That comes from the sulfate. So this is zinc carbonate plus sulfuric acid. Sulfuric acid. Yeah, let's convert it to an equation. So zinc carbonate, which is zinc is always a +2, plus sulfuric acid goes to zinc sulfate plus carbon dioxide plus water, and it should already balance. It does. Tick it if you got it. It's hard, that. Next, magnesium nitrate and hydrogen. So this is magnesium metal, and I know it's magnesium metal because it's produced hydrogen gas. Metal plus acid, salt plus hydrogen. And my acid was nitric acid because of the nitrate. Nitric acid. Convert to symbol. Magnesium metal plus nitric acid goes to magnesium nitrate, Mg brackets NO3 twice, plus H2. Balance the equation with a 2. Hard, guys, these are level 9s. These are really pushing the boundary. Right, this is a clever one, ammonium nitrate. So we know that we've got to have added ammonia. Ammonia. Just check. I always check my phone whenever it beeps in case, because I gave one lesson one time where it my YouTube channel stopped working for some reason, and they had to tell me. Plus nitric acid, because it's a nitrate, and I'm done. Let's convert it into a symbol. Ammonia, NH3, plus HNO3. Sorry, NH3 plus HNO3 goes to ammonium nitrate, no brackets, because it's NH4 plus and NO3 1 minus. Next, potassium oxide plus potassium chloride. That's right, the chloride tells me the acid. This is hydrochloric acid. Hydrochloric acid, yeah. And then if it's an oxide, I'm also going to get water. Convert to formula. HCl plus K2O. That's tricky, that, folks. Goes to KCl and water and balance. 2 potassiums, 2 potassiums, 2 hydrogens, 2 hydrogens, and we're good. Tricky, that. Another tick. So it's a lot of ticks here. Loads of them. Lots of marks. Next, calcium hydroxide plus citrate. Oh, it's with citric acid. I'm sorry, guys. That's why they didn't want the symbol equation. Citric acid, calcium citrate plus water. Wow, that one was hard. I hope everyone Googled that one. Oh my God, do you want to see the equation for that? Flipping heck. Citric acid looks like this. Blimey, citric acid. Haven't drawn this in a while. This is citric acid. You guys are going to be like, how the heck am I meant to know that? You're not. I only know it because I'm a nerd. Here's citric acid. That's citric acid. Let's convert it to that's the displayed formula. Displayed formula showing all the bonds. Its molecular formula will be HOOC CH2 C brackets OH brackets COOH brackets CH2 COOH. plus, what did we add to it? This is so crazy. Plus calcium hydroxide, holy moly. Plus calcium hydroxide, what a nightmare. Right, now it gets even worse here, guys, because the problem is, such a nightmare. Because this has got 3 acid groups. That's an acid group, that's an acid group, and that's an acid group. And this is a di-base, so it can accept 2 protons. So I'm going to need 2 of these and 3 of these, because the common denominator, therefore, is 6. This is going to give me, therefore, 6 acids, which is 6 H pluses, which is H plus, and H plus, and there's 2 of them, so 6. This is going to give me 6 bases in form of the 6 OH minus ions, because each calcium hydroxide contains 2 OH minuses. So therefore, it's going to be a nightmare. Yeah, therefore, I'm going to have 3 calciums. So it's going to be, it's an absolute nightmare, this. 3 calciums in total, and then open brackets, oh my goodness, and then all of this is an ion. Then lose this, I lose this H, I lose this H, and I lose this H. So OO minus, C, by the way, this is like first year degree chemistry. Lol. OH bracket COO minus, close brackets, CH2 COO minus, close brackets, 2. And we're done. Happy to join your live stream. Oh, Zakaria, so nice to see you. Thanks for coming along. And it's plus water. We're always going to get plus water, plus H2O. The question is, how many H2Os are there? Well, if there's 3 calciums, how many waters is this going to make? Yeah, so it's going to make 6. 6 waters. That makes sense. Blimey, what a mess. Guys, that there is insane chemistry. Cool, though. It just shows what you can build. I haven't learned that. I'm building it. It's kind of cool, right? Right, guys, that brings me to the end. So the marks for this one is now based on what they asked you to do, 2 to 9. So 1 mark for that one. So for question 1 there is 1 mark, then 2, 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 then 1. So that's 16, 17, 18. It's out of 18. Right, guys, how many out of 18 did people get? That was hard, man. That was challenging. Hey, Hashim, nice to see you, dude. Thanks for coming. How did people get on with that out of 18? That's really hard. That brings me to the end of my lesson. So I'm going to have to rename my YouTube video, Acid-Base Reactions Homework Review. Out of 18, guys, how did you get on? Brings me to the end of my YouTube lesson. Oh, what fun that's been. I've really enjoyed that. I'm not going to lie. The bit that's made me the most entertaining for me was the last one because it's really cool. I do love that. It's really neat. Technically, by the way, you don't actually... 17. Well done, Zaina. Is this including the balancing equations? If you don't balance, you'll... Oh, Jack, 3 out of 18. What happened, dude? What happened? What did you forget? Jack, what happened, man? 18 without the equations. Oh, you don't actually need the charges in that. If anyone's curious, you don't actually need the charges in it because you don't show the charges on the calcium. It's just I'm doing it. Anyway, Jack, okay, so I've got a very specific question for you then, which is me going through it, Jack, has it helped? Do you feel like you've solved the problem? And would you like me? No, I got 3 wrong. Oh, thank goodness for that. That freaked me out, Jack. I was so worried then, dude. Oh, you really worried me for a minute. Oh, okay. Can I say, guys, for you to be getting... I need to tell you how impressed I am. Stop share screen. Guys, I am so proud of you all because those equations, I can tell you for a fact, my A-level students would find those challenging. They're hard. If you're working at that, you are working at a very, very good level. I really hope that this webinar has helped everybody in how to construct them. If you've got any particular questions, please, please, please do let me know. I understand that I haven't done the process of building all my ions in this lesson, and so just let me know if you want me to expand on any of them. Otherwise, guys, go and have a lovely rest of your day, and I'll see you all very soon. Oh, year 10, can you please add your scores to the score sheet? I'll post that on the chat now. Have a good day, everybody. Take care. Bye now.